even begin, again, I want to give you a visual of what this is all about, okay? So, what I'm trying to do is three-dimensionally, I'm looking at 3D space. So, technically, there is a three-dimensional space. The x-axis comes out toward you. The y-axis is the one that goes horizontally, and the z-axis goes up and down. In space, when you're looking at stars, they use this coordinate system to find stars in space. They call this the zenith. In space, zenith is always the one right above it. Yeah, Retta? Oh, I did. Thank you, Retta. Yeah, X, Y, Z. There you go. Yeah. The X comes out at you, the Y is horizontally, and Z is up and down. Okay? So, our objective is to find the intersection of three planes. Okay? 3 planes, okay? We know that if you have x plus y equals 5, that's a line, right? That's a line. X plus y equals 5, that's planes. Oh, gosh, you guys, sorry. So x plus y equals 5 is a line. So therefore, x plus y plus z is a plane. So these are 3 planes. These are all planes, okay? In three-dimensionally in space, plane is just a flat surface. So three-dimensional in space, a plane is a flat surface anywhere in space, okay? But we know it goes on forever. And the best I can show is just a piece of paper with a plane. We know this plane extends in all directions forever, okay? Mathematically, okay? If we put all 3 of these together, they can intersect in a point. They can also be no solution, because the planes could be parallel. I mean, you can visualize parallel planes, right? They're parallel, no solution. They could intersect in a line. If they intersect in a line, that means you have an infinite amount of solutions, right? But what we're trying to find is when they intersect in one plane. So plane 1, plane 2, plane 3. In fact, I'm going to label my planes. It helps me to stay neat on this, so I'm going to have a plane 1, plane 2, plane 3. We're going to solve them by the elimination method. We really are. It's going to be the same process.
Is this the three equations? Something Mr. Brown was talking about that we're going to do.
Yes, we are going to do the elimination with 3 variables. So, the way this works is you're going to pick any 2. Pick any 2. So first step is pick any 2. 1 and 2 are good because I can cancel out the z's easily. See that?
And the y.
I could also pick and the y's, right? Yes. So, yeah. So 1 and 2 are a good choice because then we can cancel out the z's and the y's, right?
Yeah.
Okay. So let's go ahead. You can pick any 2, but you need to pick. So pick 2 equations. You can pick any 2, okay? So I'm going to pick probably, let's pick 1 and 2. I'll pick these 2 right here. So I'm going to rewrite them. Equation 1. Equation 2. Okay. And the reason I picked those 2, you guys saw it, is because it's an easy elimination. So I wanted to start off with an easy problem. This should be an easy problem. I'm hoping so. It was made simple. The reason it was made simple is because when I do add, the y's cancel, the z's cancel. 2x equals 4, right? Or x equals 2.
Now, I'd like to make my problem easier. So if I put the 2 back into all 3 of these equations, then the problem gets easier. So I'm going to plug in x equals 2. So let me rewrite equation 1. So equation 1 is now going to be a 2 plus y plus z equals 1. Equation 2 is a 2 minus y minus z equals 3. And equation 3 is going to be a negative 2 minus y plus z equals negative 1. Okay? Let me simplify it a little further. Okay? Equation 1 is really going to be, if I bring over the 1, I'll have a y plus z equals negative 1. Okay, subtract 2, you get the negative 1. Equation 2 is going to be a minus y minus z equals, if I subtract my...
How'd you get 1?
minus 2 minus 2.
Oh.
Minus y minus z equals, let's see, if I go minus 2 minus 2, I get a positive 1, right? Equation 3, I'm going to have a minus y plus z equals positive 1, okay? How am I doing? So now, I'm going to pick 2 and 3. So if I pick equation 2 and equation 3, hopefully you'll see why. And I can add these two. I picked 2 and 3 for a reason, because then the z's will cancel, right? So that's like a negative 1y and negative 1y. Am I going too fast?
Yeah.
Okay, I'll slow down for you, okay? So the first thing I did is I picked 2 equations to get rid of a variable. In fact, I got rid of 2. That was kind of nice, right? Okay. Then I rewrote my equations. And now I'm with what I did yesterday. I picked 2 and 3 because I saw the z's will cancel. And then I will get a negative 2y equals 2 because those cancel. I'll get y equals, divide by negative 2, divide by 2, I get negative 1, okay? So I have 2 answers, okay? I don't know z, but I can substitute, and I'll wait for you, okay? So the last thing I'm going to do is to find z. We're going to plug x equals 2 and x equals negative 1 into one of the beginning ones, into first 3 equations.
Y equals
Right? Question?
you mean y equals
Yes, did I? Yes. Yes, yes. Thanks, Retta. Boy, I'm making mistakes today, aren't I? So if I go back to the beginning, let me push it like this. Okay, if I go back to the beginning. And plug it into idiom, okay, but I think the first equation is easier. But if I put 2 here and negative 1 here, you'll get z even, right? Or I can put 2 here, negative 1 there, but I think equation 1 is the easiest. So if I can put 2, because that's x, negative 1, because that's y, we'll get z. So I'm going to do that. Okay, we'll practice this again. Okay, so then I'm going to take, I like this equation right here. I'm going to go my x plus y plus z equals 1. I know x is equal to 2, y is negative 1, plus z equals 1. I'll have a 1 plus z equals 1, because I just combined those two to make a positive 1. Minus 1, z is 0. Okay, now I have all three. My answer is a point in three-dimensional space. It really is. So here's my answer. Answer should be x, y, z. We need to practice this again. We do. We do. So we're going to turn the page and we're going to do another, okay? Okay? Don't worry. You're not going to get a lot of these for homework. You agree? Maybe 2 problems and that's about it, right? Yeah, just 1 problem, yeah. Okay, turn the page, but here's how I graded. Here's how I graded. If you do our work correctly, you get it right. If you get the question, you get a bonus point. Can you see how many places I can make mistakes? Okay, turn the page. So if we turn the page, let's do it again. Okay. All right, so equation 1, equation 2, equation 3. Pick any two. Any two. Pick any two. Okay, 1 and 2, and so we could probably get rid of the y's, right?
Yes.
Okay, you guys agree?
Yeah.
We pick 1 and 2 and get rid of the y's. Okay, I like 1 and 2 because it's a good choice. Okay, so pick any two and get rid of a variable. So I'm going to pick. I like picking 1 and 2. I think it's a great idea. 1 is x minus 2y minus 3z equals 11, and equation 2, 2x plus y minus 2z equals 9. Okay. I think everybody agrees we should probably multiply equation 2 by positive 2, so I get a 2 there. Okay. I'm going to rewrite these. To save room, I'll rewrite them over here. Equation 1. So I'm going to rewrite equation 1, equation 2. Equation 1 I'm going to keep as an x minus 2y minus 3z equals 11. Equation 2 will make a 4x plus a 2y minus 4z equals 18. Okay, and I'll wait for you, okay? So I'm going to eliminate y's, correct? I'm not going to have any answers yet, because I'll still have x and z. But the y's will disappear. Agree with that? So let's add them together, and the y's disappear. So if I add, I get a 5x minus a 7y equals 29. Okay, now we made a new equation. Thank you. Gosh, why do I keep making these mistakes today? I'm thinking about what I want to say instead of writing the question. So we made a new equation. So let's call this equation 4. We made a new equation. Call that equation 4. Now, we need an equation 5 that lines up. We need an equation 5 that lines up. So we're going to make an equation 5. So we're going to go back and we're going to pick another 2. This time, I'm going to pick 2 and 3. You know, I want you to know why I'm going to pick 2 and 3. So I got rid of the y's, didn't I?
Yes.
I need to get rid of the y's. I need to get rid of the y's again, so I got x and z's. So 2 and 3 seems pretty easy, right? See if I get pick 2 and 3, I can get rid of the y's. If I get rid of the y's, I'll have x's and z's, which lines up. Okay? That'd be equation 5, and then you go through what we did yesterday. Okay, so does that make sense? I could do it here, but that means more multiplying, right? That means more multiplying. Yeah,
Why are you making a 5th equation?
because then I have a 5th equation, 5 and z, and then we're doing what we did yesterday. Remember how we did yesterday? Yesterday was just x and y. So remember what we did yesterday with our x's and y? What I did this morning for the first 20 minutes?
Yeah.
was elimination. So I want to do an elimination with an x and a z. To line up an x and a z. So I'm going to use these two to get rid of y, and I'll have an x and a z, okay?
Right? This is hard, isn't it?
Remember multiplying the top one by 3.
So, yeah, let me rewrite equation 2, which is my 2x plus y minus 2z equals 9. And equation 3, 4x plus 3y plus a 1z equals 16. Here's what you have to know.
You need to make an equation 5. You have to have an equation 5 that works with equation 4. You need an equation, so we cancel out the y's. We need to cancel out the y's so it matches up to equation 4. Does that make a little bit of sense?
Would it have to be?
Yeah, we're gonna have to do something. Yeah. See, you do know some things, don't you, huh?
All right, I agree with Paige. Let's multiply equation 2 by a -3. Okay, so let me rewrite equation 2. Rewrite equation 2 as a -6x minus 3y positive 6z equals -27. We'll have a 4x plus a 3y plus a z equals 16. And I'll wait for you, okay? So now when I add 2 and 3, I'll get a -2x plus a 7z. Is that -9? Probably, right? No, or is that 11? That's -11, right? 16 minus 27, -11. Okay, you've made an equation 5. So let's put equation 5 and equation 4 together. Oh, this isn't bad. Equation 5 comes over here. So I've got a -2x positive 7z equals -11. And now we're right back to what we did this morning, right?
Well, this is easy. We made it easy for ourselves, didn't we? See what's going to cancel? I don't need to multiply anything. It's nice. Switch this down. I'll get a 3x equals whatever, 28 or something like that. Yep.
Okay, so add them together. So I got a 3x equals 28. Divide by 3, divide by 3.
Divide by 7.
Divide by, no, that cancels.
How did you get the 28?
Is it 8? Oh my goodness. Yeah, I can't.
It's 18.
It's 18. Golly. Got a math teacher that can't add or subtract. 18, thank you. X equals 6, okay, right? Okay, we got x equals 6. Let's find z. How am I going to find z? Let's plug it in. I think the best and easiest place to plug the 6 in is right here. You okay with that? Okay, you all right with that? So take 6.
So we're only plugging it into our fifth equation?
Yes, because that's just x and y's, right? Or x and z's, right? And then we can get z, right? So if x is 6, plug it here because if you plug it up here, you can't find a variable, right? So if you plug it here, you go -2 times 6 plus 7z equals -11, right? -12 plus 7z equals -11. Plus 12 plus 12. Is that only 1? Equals 1. Z equals 1/7. Darn it, I must have made a mistake somewhere.
No.
It's okay, we're going to go on. I know, exactly. Must have made a mistake somewhere. So then to get y, I just pick any of them. If I pick equation 1, well, yes, I will discuss that. I'll finish it. I'll tell you what we're going to do. X is 6. Y is, we don't know y. Z is, 1/7, right?
Is that a 7?
That's a
Or is
7.
that a Z?
Yeah,
That's a 2.
Z value.
Well, I'm confused. Are we working on the next
Yeah, we're
question?
working on the
or-
next
No, it's the same one. It's the same one. Right?
So do we know, so my question is this, okay, I'm sorry. I'm looking at the time, I'm worried about running out of time. So here's the good news, no homework. Here's the good news. And I'll probably move this to there, but anyway, I'm not done yet. So here's the deal, before the bell rings, you know X, don't you?
Yeah.
You know Z.
Yeah.
What's Y?
1/7.
What's Y?
1/7.
We don't know Y.
Oh, wait.
Oh, we don't know why.
So that's what I'm explaining why. I'm looking to find Y. But I'm gonna get Y before the bell rings, okay?
I plugged it into the very first equation. I used the first equation, okay?
So this is basically what it would look like, right?
Yeah.
Put that away. Here you go. I'm gonna throw it at you. I'm not gonna catch it.
All right, we will pick this up tomorrow. Now, before the bell rings, I got 1 minute, right?
You got 1 minute.
Don't nobody go anywhere.